Welcome, ethics team. What you're seeing right now is the same Simplot potato, but in one of them, the trademark innate one, CRISPR, a gene editing technology, has tweaked the RNA interface and genome by adding and removing a few genes. The agricultural company Innate now markets its superior potatoes without having to worry about the major challenges traditional potato farmers face, such as black spot bruising, high concentrations of carcinogenic acrylamide, and late blight diseases that can wipe out whole harvests. Sounds pretty good, right? After all, who wants bruised, toxic French fries when they can have the perfectly clean and unscathed innate ones anyways? Well, the answers may not be as simple as they seem. Aside from their superpower potatoes, innate also raises numerous ethical questions. Who will be responsible if something goes wrong? How will they affect the environment, our health? Should they have a new label for the consumer? And the list goes on. All these are important questions, but today on Crash Course Ethics and Technology, we're here to tackle perhaps the single most pressing question regarding the genetic engineering of crops. What principles should inform the way we use genetic engineering when it comes to crop production? A 2012 UN Food and Agricultural Organization report listed that globally over 868 million people were suffering from hunger and malnutrition. The human population is projected to reach 9 billion by 2050, and some estimates show we may need to double our agricultural production rates by that time if we want to feed everyone. Growing populations will increasingly encroach upon the diminishing arable land, making increased agricultural productivity on the remaining farmland an urgent necessity. Genetic engineering crops will almost undoubtedly play a role, whether it be detrimental, heroic, or somewhere in between, in solving this major problem. Innate and other companies using CRISPR and other gene editing technologies are taking traditional GMOs to the next level. In fact, crops like the innate potato fall under a new category of GMOs. They are not merely genetically modified, they are genetically edited organisms. They give scientists even more precision and power to make crops exactly how we want them. If you're unfamiliar, GMOs in this context are plants that have been in some way engineered or altered by humans. An example is when scientists artificially select for a certain trait that makes larger, juicier varieties of peas. Recently, it has been estimated that 93% of the corn, 96% of the cotton, and 94% of the soybeans in the U.S. are genetically modified varieties. Moreover, with the use of CRISPR and other technologies, these genetically edited organisms are on the rise and offer even more potential for expansion than their standard GMO counterparts. As you can probably imagine, these GMOs and now GEOs pose quite a few ethical questions, but the one that concerns me most, and the one that we're here today to answer, is what principles should inform the way we use genetic engineering when it comes to crop production. To start to answer this, it might be helpful to get some assistance from this episode's Philosopher of the Day. Meet Harvard political philosophy professor Michael Sandel. In response to the idea of genetically enhancing humans, Sandel's article, The Case Against Perfection, urges us to consider the moral status of nature and thinking about how we, as humans, should view the world. To quote Sandel's conclusion of sorts, the problem with eugenics and genetic engineering is that they present the one-sided triumph of willfulness over giftedness, of dominion over reverence, and of molding over beholding. In essence, Sandel sees genetic editing and enhancement as the imposition of victory of human will and ingenuity over the course of the natural world. It is a victory that comes with terrible costs and consequences. When awe-inspiring feats are the product of test tube engineering rather than prodigious talent, they are drained of meaning. Sandel believes most of the current objections to human genetic enhancements, such as there may not be equal access to these enhancements, distract and are less important than the bigger question he wants to address. Should we even be aspiring for these human genetic enhancements in the first place? Sandel contends that we shouldn't strive for these enhancements primarily because of the danger that this hyper-agency poses. When we drive ourselves to become masters of nature, it transforms our human nature and our moral landscape. We lose our compass, our capacity to recognize the giftedness, the idiosyncrasy that comes from nature. So there are three reasons for this. First, we lose our humility. We will be self-made and lose any sense of giftedness or help that got us to where we were because we enhanced ourselves. Second, we erode our responsibility. Along the same lines, then, we attribute less to chance and more to choice. The example Sandel gives is that we begin to blame the basketball player who doesn't get the rebound, not because he didn't get good positioning or anything or box out, but because he's too short. Finally, the third thing is that we feel less solidarity. It would be harder to have the same sense of social connection through things like life insurance if our genetics are controlled and randomness is out of the equation. We simply won't feel any obligation to help each other like we do now, because as it is now, we recognize the value of our gifts individually and the gifts that others have or don't have. So I think Sandel gives a strong argument about genetically engineering humans that actually may be applied to the genetic engineering of food. However, while he raises compelling points about moral consequences and problems in connection to the genetic engineering of humans, I don't think that his argument is as persuasive in that respect to genetically engineering crops. Moving forward now, I'll construct an argument that the principles Sandel raises in his case against genetic enhancement of humans are problematic when it comes to genetically engineering crops. Editing genes to treat disease in sick humans is not where Sandel sees a moral quandary. Sandel sees treating disease as actually allowing human natural capacities to flourish. He also contends that medical intervention on humans does not desecrate nature but honors it. Sandel would also not see editing plant genes to treat or prevent sickness in humans or feed large numbers of people in need as a moral quandary. The same way editing a cancer-causing gene out of a baby is not a moral quandary to us, editing genes that produce cancer-causing compounds in the simple potato is also not a moral quandary to us. Another example of this more humanitarian use of GM agriculture is golden rice, which aids over 250 million preschoolers who are vitamin A deficient by supplying 60% of the recommended daily intake of vitamin A to many of them. Or in the case of the Green Revolution, GM agriculture enabled America to feed many people by significantly increasing crop yields. Like editing genes to save humans from disease, editing or genetically modifying plant genes to prevent disease and feed humans allows human natural capacities to flourish, to quote Sandel. Therefore, Sandel's argument does not fully apply as a governing principle over the use of genetically engineered crops. So I think my argument here raises a solid point, but I also believe there's a necessary objection to also consider. I think Sandel, or someone taking the stance of Sandel, would potentially push back against this conclusion because a key component that he touches on in this article can and should be involved in this discourse. Genetically engineering crops do, however, cause the same issue of hyperagency that Sandel mentioned. Sandel highlights that it is not the mastery or perfection itself that is the greatest issue, but rather the disposition that it creates. Along these lines, the seemingly humanitarian or utilitarian model for GM agriculture dangerously reduces the issue we face into nutritional components and crop yields, failing to recognize the political, social, and cultural aspects of this issue. So, going back to the question and concluding the video, clearly it's very difficult to address the exact principles that best inform the way we use genetic engineering when it comes to crop production, even with the help of Sandel. The best sort of answer I, as a 17-year-old, can offer based on all my philosophical thinking is that the genetic engineering of plants should heed the warnings regarding a hyper-focus on mastery and perfecting nature, as these can leave unaddressed the numerous systemic issues that we have in our food system. However, the genetic engineering of plants indeed can prove, and has already somewhat proved in previous cases, to be highly beneficial across the board if they are implemented thoughtfully and as a sort of medicine that honors and appreciates nature. So what do you guys think of the argument and objection I've constructed here? What lingering questions do you have? Can you think of any other principles that ought guide us when we proceed with the genetic engineering of plants? Anyways, I hope you guys enjoyed this episode of Crash Course Ethics and Technology, and I hope to see you next time.